Alright students, let's start now. A gas occupies 500 centimeter cube at normal temperature. At what temperature will the volume of the gas will be reduced by 20% of its original volume, pressure being constant. Now pressure being constant, they are asking about Charles law. So now let us solve this question. V1 that is equals to 500 centimeter cube, but this volume is reduced by 20%, so I'll write let v1 be equals to x. So v2 will be x minus 0.2x, okay, reduced by 20% of its original volume, so that will be equal to 0.8 of x. And they are giving us temperature to be normal, that means T1 is equals to 273 Kelvin. Alright, now V2 they are putting the question mark, so apply Charles law. V1 by T1 that's equal to V2 by T2, so that implies x upon 273 that's equal to 0.8x upon T2. So x and x will get cancelled out. So T2 is equals to 0.8 into 273, and the answer will be 218.4 Kelvin. Don't convert into degrees Celsius until and unless the question is asking you that convert it into degrees Celsius. So right now you can keep it as T2 is equal to 218 Kelvin. This is the correct answer. Alright, now let's go ahead with the next numerical, 13th numerical. Asking the final volume of a gas X if the original pressure of the gas at STP is doubled and its temperature is increased 3 times. Alright, now they are asking final volume of a gas if the original pressure of the gas which is at STP is doubled and its temperature is increased by 3 times. Okay, now we are not having its volume, initial volume, we are not having its initial volume, they have not given us. So what we are going to do, let V1 be equal to x. Now here pressure is getting double, temperature is increasing 3 times, so comparative study only. So what I will be writing, let V1 be equals to x, P1 be equal to y, and T1 be equals to z. So now initially it is STP which is getting doubled, so V2 we have to find, that means it should be comparative study between V1 and V2. P2, that pressure is doubled, that means it is 2y, and temperature is increased 3 times, so T2 is equals to 3z. Now apply combined gas law, because you have to calculate everything, combined gas law, and after applying combined gas law, that is P1 V1 upon T1 equals to P2 V2 upon T2. So what will happen, P1 is y into V1 is x and T1 is z, that is equals to P2 is 2y, V2 is to be found, and T2 is 3 times of z. So z cancel out, y cancel out, so V2 will be equal to what? When you make V2 as the subject of the formula, will be equal to 3x divided by 2. That means final volume will be, final volume is 3 by 2 times of initial volume. That should be your answer. Let that volume be anything. Alright, so but V2 will be always 3 by 2 times of its initial volume.